Good morning. Today I will talk about user authentication. User authentication is another important technology we need to use for design security system. User authentication is the process of verifying an identity claimed by or for a system entity. Let's first get the pen. For example, for some website, we have some resource there you need to access. But for this website, they need you to enter your credentials so that you can access the resource. Not everybody can access the resource. So the user will enter their credential first. So after the website accepts this credential, they will send it to the authentication server. So the authentication server will looking for a match in the server. If it found a match, then the system authorizes the user and the access is granted. There are many means of user authentication. The most used now is password-based authentication. For example, for your computer, you want to log in, you have your username and password. Also, for some Amazon account, you also have some username and password to access your account. Besides the password-based authentication, also we have biometric-based authentication. Use the face, voice, fingerprint, and so on. Besides, we also have token-based authentication. Generally, this means smart card. Okay. Besides these three, the bunch of other means. We will talk about the first two. First, let's talk about the password authentication. This is the mostly often used way. The basic idea is user has a secret password. Then the system checks password to authenticate user. For this way, there are several issues there. One is how are passwords stored? The second one is how does system check password? The third one is how easy is it to guess the password? If your password is set very simple and easily guessed, that's not good. How to store the password also is important. For example, you can store your password as plain text, or you store your password as encrypted file. There are a bunch of ways there. Long time ago, in your computer or in a network server, your username and password are stored in plain text. So if you go to your computer, you will find the user ID and password there. So that's easy for you to memorize. Also, it's easy for other people to memorize. For example, if several people use the same computer, then everybody can access these password files. Then Bob wrote his own password also know other people's password. That's the one issue. The second issue, sometimes if your computer was left there unattended, other people also know your password. So it's not secure at all. So there are other ways to store the password. That means when you store your password in your computer or some server, you don't store your password. You store your hash code of your password. For example, for Bob, his password is this one. Okay? We not store the password in the password file. We store its hash code. Okay? For example, the MD5 hash code of this password is this one. So I will store this value in the password file. The same for Tom's password is this one. I don't store its password here. I store its password's MD5 hash code is this one. Okay, so we store the hash code here. For the Nico, the same. Also, we store his hash code. So this is the hash code we store on the file. So even Bob, Tom, and Nico can access the computer. They don't know other people's password. They just know the password hash code. So how does this system work? Firstly, you need the select hash function. In our exam, the hash function is MD5. Okay, it's MD5 I show here. Okay, that's first step. You need to select hash function H. Not just the MD5. There are a bunch of hash functions you can select. Then a user password is stored as the hash code. Okay, you put your original password as the input, then compute the hash code. Use H. So this hash code will store on the computer. So when the user enter password, first the system will compute the user's hash code. This hash code you entered just now will compare with the hash code stored in the password file. If they match, that means your password is correct. Then let you log in. If it does not match, that means your password is not correct. Then you cannot log in. The real password are not stored on disk. If you really want to store the original password, you can store in another machine. For example, if an offline machine, okay, or highly secured server. There are two password stored way based on the hash code. The first scheme is what we talked just now. You have a password, okay? Then you get its hash code, okay? Then this hash code will store in the password file. That's the first scheme. We have a second scheme. Second scheme, that means before you hash the password, Okay, this is the password. This is the hash algorithm. So before you do the hash algorithm, we put some sort after the password. What's sort? A sort is a non-secret unique value which is append to the password before it gets hashed. In this case, the sort is the time. For example, when you create your password, then they attach the time you create the password after the password. Then you get a new sequence. So this sequence will send to the hash code algorithm. Then you get the hash code. Okay? After that, the hash code will stored in the password file. Also, the password file will include the sort. In the original scheme, we just have the hash code. Okay? But in the scheme with the sort, there are also sort values stored in the password file. Why we put sort here? There are several benefits to use sort. The first one, it can prevent duplicate password from being visible in the password file. Even if two users choose the same password, those passwords will be assigned different sort values. Thus, the hashed password of the two users differ. That's the first benefit. The second benefit, it greatly increases the difficulty of offline dictionary attack. For the dictionary attack, they will just check every password, then match your password in the password file. If you add sort there, and we assume that the length of a sort is b bits, then the number of possible passwords is increased by a fact 2 raised b. This will increase the difficulty to guess the password in a dictionary attack. So you need to match more password there. The third benefit is that it becomes nearly impossible to find out whether a person with password on 2 or more systems has used the same password on all of them, because I add different sort in different systems. That's for the password-based authentication. Another way for user authentication is to use biometrics. In biometrics-based user authentication, it uses a person's physical characteristics such as fingerprint, voice, face, keyboard timing for user authentication. There are many advantages for biometrics-based user authentication. The first is that biometrics cannot be disclosed and forgotten. But there are also disadvantages. The first disadvantage is that it's costly. You need to install and maintain a biometrics system. The second disadvantage is that the reliability of comparison accuracy is an issue. For example, sometimes it costs too much false positive. Sometimes it costs too much false negative. If the system costs too much false positive, it will allow unauthorized persons to access the system. If your system costs too much false negative, then it will disallow authorized person access the system. So these are the two disadvantages. There are many types of biometrics. The first one is DNA. In fact, DNA is one of the ultimate unique code. Generally, the identification accuracy is very high. However, it has some shortcomings. For example, identical twins have identical DNA patterns. That's the first one. The second shortcoming is that the DNA is easily contaminated and sometimes it's sensitive. The third issue is it's not real time. Besides DNA, there are a bunch of other biometrics we can use for user authentication. The first one is the ears. Okay, we can use the shape of the ears, especially the structure of the cartilaginous tissue of the pinna, to identify the identity of the user. Face is another example for biometrics-based user authentication. In fact, in our daily life, face is used by human beings to recognize a human. For face identification, we can use the location and shape facial attributes. Sometimes we can also perform overall analysis of the face image. For face recognition, generally we have 3 steps. First, we need to detect the face. To find where there is face in the picture. The second, we need to locate the face. Because when you take a picture, the face part is just a small region in the big picture. We need to find the location of the face. The third step is recognize the face. Face has been used for bank security and entrance control and so on. Fingerprint is the most widely accepted biometrics. I remember in iPhone, some model they use the fingerprint as the user authentication. For fingerprint, because the pattern of friction ranges and varies on an individual's fingertips are unique to that individual, so we can use it as an identification way for user authentication. For fingerprint, you can use a single finger or multiple finger. If you combine multiple finger, their recognition accuracy will be high, but the processing speed will be low. We also can use the gait of a human being for user authentication and use hand and finger geometry, okay, as the biometrics to perform user authentication. For example, you have a camera, okay, you just put your hand there, then the camera get your hand, okay, then process it to compare some template in your computer, then let you log in or not log in. Another biometrics is iris. This identification method uses the unique texture of the iris. For example, for identical twins, you cannot identify them use DNA, but we can identify them use iris. Another benefit is that iris is difficult to surgically tamper. Okay, you cannot make the texture of the iris. Besides the biometrics we talked about above, there are more other biometrics. For example, for the retinal scanner, this is the most secure biometrics. It reveals some medical conditions. Another biometric is signature. For this one, you can just use the hand, okay, to sign, okay, to get your signature, then use it as a authentication way. But the shortcoming for this biometrics is that professional forgers may be able to reproduce signatures that's for the system. Another biometrics is voice. Voice is the combination of physiological and behavioral biometrics. For the voice, also I suggest it's not good because sometimes you can record some people's voice, then make an artificial voice similar to other people. Then you can cheat in the system. When we talk about biometrics, there are many ways you can get the biometrics. For example, for the face, you can use the normal camera. Also, you can use the infrared camera. For the hand, also you can use the normal camera. Also, you can use the infrared camera to get the image. So there are many ways you can get the biometrics. The benefit for the infrared camera is that they can work in dark condition at night. But generally for this kind of sensors are very expensive. There are so many biometrics-based user authentication. So some are good, some are not good. We need some performance metrics to compare them. There are many performance metrics. I list here just some of them. The first one we called uniqueness. Uniqueness means each individual should have features but different with others. The second is permanence. Permanence means the biometric should be there permanently. You cannot say they change it daily. If it is there today, then change it tomorrow. Then you cannot use for user authentication. The third is universally. Universally means the population coverage, not just 1 or 2% person have this kind of biometric features. There should be many people, a lot of people have this kind of biometrics. Then you can use it as a user authentication tool. Another performance metric is measurability, which means it is measurable with simple technical equipment. It means simplicity of extraction of the biometrics. Another one is comparability. Comparability means simplicity of comparison between two templates. One is stored in the computer. Another is live. If it's difficult to compare the live and the stored, that's not good. Another thing we need to think about is collectability. Collectability, that means how well can the identifiers be captured and quantified. Okay. Also, one thing we need to think about the invasiveness. Invasiveness, that means your equipment to get biometrics to go inside your body part or not. If it go inside the body part, that's not good. For example, for the DNA, generally required blood of testing. For the fingerprint, you use your finger to touch the equipment. But a face, that is good. We don't need to use your face to touch the equipment. We just use camera to get your face. So from this viewpoint, the face is better than the DNA and the fingerprint. Another thing is the performance. Performance, in fact, is very important because it's related to the accuracy, speed, and security. Also, we care about acceptability. Acceptability means whether your biometrics way is accepted by the person. If some people reject you to do so, that's not good. For example, many people don't want to use the fingerprint. The last one is called circumvention. Circumvention, that means the act of cheating someone. Is it easy to create false biometrics so you can cheat the system? All of these kind of metrics we need to consider when you design biometrics-based user authentication. I got this table from some paper. They show the performance of different biometrics. For example, for iris, the uniqueness is high, the permanence is high, the universality is high, the measurability is middle, the comparability is middle, the collectability is high, the invasiveness is middle, the performance is high, accessibility is middle, the circumvention is low. Okay, the circumvention is low, that means it's good because it's difficult for you to make the artificial iris. Besides the iris, there are many other things I just show here. You guys can go then one by one, then understand which one is the best, which one is the worst. Biometrics-based user authentication has many applications. For example, it can be used for bank, okay, entrance access control, okay, PC login. There are many other things. However, there are also some limitations for the biometric system. One is there noise in the sensor data. Okay, this noise will affect the performance of the system. For example, this is the fingerprint, have good appearance, but this one is not good, have many noise there. Also, there are many broken parts in the fingerprint. Another thing is for the intra-class variation. For the same person, perhaps the variation are big. For example, for face recognition, you have different poses that will affect the recognition. Another thing is distinctiveness. For example, hand geometry. Perhaps two persons have similar hand geometry. For the face is the same. That many people have similar face. So that's another issue. Also, some biometrics is non-universality. Not always everybody have. For example, for the fingerprint, some people does not have the fingerprint. Another limitation is spoof attack. For example, fingerprint, the people can make artificial fingerprint. In fact, because the 3D printer is popular now, many things can be made by 3D print. For example, 3D face, 3D hand, and so on. So that's make the biometric system looks challengeable. Just now we have different biometrics way for user authentication. For better performance, generally we combined multiple biometrics. For example, we can combine face recognition and voice recognition, combine fingerprint recognition and face recognition for user authentication. Also, you can combine biometrics with PIN, okay, and combine biometrics and token, and so on. This just shows the generic biometric system for authentication. There are two steps when you use this system. The first, you need to enroll the biometrics in the database. For example, you have a person, you want to let him use your computer. First, you need to register him in your system. Then you get his fingerprint, okay? Use some sensor. Then extract the future, then store the future in the database, okay? That's for enrollment. So next time, when this guy uses your computer, they need to touch his fingerprint on your sensor, okay? Then the sensor get his fingerprint, then do future extraction. Then the extracted features and the features stored in the database compared, okay? If they match it, then we authorize the user to use your computer. If not, we just reject it. That's all for the biometrics based user authentication. Because there are many mathematics here, I did not show here because it's very difficult. In fact, for the biometric system, generally it involves machine learning. Currently, the deep learning is the most popular technology used for biometric system. If you guys are interested in, I can put some paper there, let you guys read. But it requires a lot of mathematics, so that's the reason I don't require you guys to go deeply. Okay.